Pre-calculus. Hello once again. This is for the week of 427. We're doing double and half angle. So the test for this week on Friday is going to be about 6 questions or so. No, sorry, it's going to be more. I don't know, something like that. It's quite a few questions, um, and it's got a bit of review from old concepts too. So let's start off with half angle. So I put this half angle for sine and cosine. There's also one for tangent as well. Cheat sheet should have it. Any source online, if you just look for half angle formulas, they should have it. I just put for the sine and cosine because that's what I'm gonna be using in this video, just so it's convenient for you guys. Okay. So first thing, the directions will ask you to use half angle. So uh, sine of 75 is what we're gonna try to find. So sine of 75. Let's go to our let's I know we do not have 75 degrees here. Yeah, 75 degrees is not here on our unit circle. However, we do have 150, simple, 75 times 2. So half of 150 is what we want to find. Because half of 150 would be 5. Sine of 75 is going to be, what we're going to use is, we're going to say that sine of 150 over 2. So we're using this, right? Okay? Sine of 150 over 2. Okay, and then we're just gonna write it out. Plus or minus square root of 1 minus cosine of theta. Now the cosine of theta would be the cosine of this, because it's theta over 2. Theta over 2, 150 over 2. So we're gonna do 1 minus the cosine of 150 over 2. And it's the square root of that entire thing. Alright, move on. That's equal to plus or minus square root 1 minus. Now let's find out the cosine of 150. Cosine of 150. Where are we? 150, the cosine is negative root 3 over 2. Back here, negative 3 over 2, all over 2. Alright, so let's get my eraser if I can find it. Here it is. Okay. Let's do a few things here. First of all, negative times negative, that's going to turn into positive, so I don't need this parentheses anymore. That's going to be positive. Here is the trick now I want to show you guys. When we have a fraction inside of a square root, like, by the way, the square root, you guys know, extends the numerator and denominator, okay? It's over the whole thing. When we have a fraction like that, there's a little trick we can do to get rid of that to make our lives 10 times easier. We're going to multiply the top and the bottom by 2. Okay, and now what that also actually does is actually rationalizes our denominator. Now, let me just show you what's going to happen. That's going to equal 2. Watch what happens here. First of all, let's do the denominator. That's the easy part. That's going to be 4 there. And up here, really, when you're multiplying the 2, you have to distribute. You have to multiply it to both of these terms. So 2 times 1 is 2. 2 times that, well, that's just going to be 2 root 3 over 2 root 3 over 2. And so what's going to happen is those 2's are going to cancel out. So essentially, the only thing you get, what that 2 does, it cancels out that 2. So it makes that a 2 plus, and then that 2 multiplied by 2 cancels out that 2. So you're just left with 2 plus root 3. I'm just going to rewrite that root 3. That's all you're left with. Okay, now we're almost done. 2 plus or minus square root. So now what we're going to do is when we have a square root, when the square root's over the whole thing, we can separate that and we can do square root of 2 plus square root 3 all over square root of 4. Okay, so that is equivalent to that. Now, why would I do that? Because simple, I know what the square root of 4 is. The square root of 4 is just 2. Perfect. Okay, now you may think that this is your final answer, but I want to caution you guys for a second. My original question was, what is the sine of 75? Okay, what is the sine of 75? This formula allocates for plus and minus, right? But the sine of 75, we know something about the sine of 75. Let's go look back at it. going to be in this quadrant right here, in this first quadrant. So the sign of 75, if you look at all the signs here, the sign is positive, 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 positive. The signs are all positive. Well, the cosines are also positive, but I care about the sign right now. The sign is all positive. So if I flip it back over, my final answer for sine of 75 shouldn't be plus or minus. So I'm just going to leave it like that. That is the final answer, and that's fine. You can leave that square root just like that. It's perfectly fine. We rationalize the denominator automatically when we multiply by 2. So we're good. This may sound a little confusing. That's why I'm going to do another one, okay? So let's do a second one. This time we're going to do cosine of 15, all right? So I'm going to erase that. This time we're doing cosine of 15. Okay, so we're going to find the cosine of 15 using half angle. Okay, so if the cosine of 15 is what I'm looking for, what I'm going to actually do is do cosine of what divided by 2? So 15 is going to be 30 divided by 2. Now, the reason I'm doing that is if you look back here, you're not going to find 15 degrees. 15 degrees not there. 30 is though, and we know 30 divided by 2 is 15. So we're going to do cosine of 30 divided by 2, yes, sorry. That equals plus or minus. And now this is going to be 1 plus cosine of theta, okay? So that's going to be cosine of 30 all over 2. All right, let's continue this problem. That's going to equal to, I should put my equal here. That's going to equal to plus or minus square root of 1 plus. All right, let's see. Cosine of 30, what are you? Cosine of 30 is root 3 over 2. That's going to be 3 over 2. It's a very similar problem than the last one, actually. All over 2. Okay, little trick here, since we have a little shortcut, I should say. It's not even a trick, it's a shortcut. To multiply top and bottom by 2. And in doing so, we're going to get plus or minus square root. 2 times 1 is 2. 2 times root 3 is 2 root 3 over 2. And then all of this over 2 times 2 is 4. Well, what's going to happen is these 2's are going to cancel out. Plus or minus square root of 2 plus, that's just root 3, all over 4. All right, take a good hard look at that, because now I'm gonna rewrite this. If I have the square root over the whole thing, I can rewrite it as just, I can separate that square root. In doing so, I will see that the square root of 4 is just basically 2. And we have our answer, but we're not quite done, because over here it says plus or minus. But I really want to look at what it's asking for. It's asking for the cosine of 15. When it's asking for the cosine of 15, if that's what the original question was asking, well, 15 degrees would be in quadrant 1 and be somewhere here. And the cosines in all of quadrant 1 are always positive. So really, the only answer I want here is the positive answer. And I don't need to put the positive. There you go. All right? That's all I need right there. So even though the formula itself says plus or minus, you have to be careful. You don't just leave plus or minus there. You have to be careful. Only put the appropriate answer. So, for example, if I had asked for the cosine of, let's say, like 200 and, I don't know, 50 degrees or 220 degrees, something like that, you know, then you'd have to be careful, because the cosines here in quadrant 3 would all be negative. So the negative would be your only answer. All right, so that's half angle right there. Not too bad. I do want to add to this video, which is a kind of a throwback question. All right, throwback question like this. And why am I including this? It's probably on your test. All right, what if I gave you something like this? I said, all right, you guys, the throwback. Tan of theta equals 5 over 12. I want you to find secant of theta, but I will tell you this, since tan of theta is equal to 5 over 12, And I'm going to say that theta is in between pi and 3 pi over 2. Pi and 3 pi over 2. Okay, so I have to tell you where it is. So let's think about that. Pi and 3 pi over 2, where does that lie? That's not first quadrant because remember, that's 0, pi over 2, pi, 3 pi over 2. Okay, so where does it lie? That means between pi, so it's right here in quadrant 3. I'm going to draw a right triangle here. And this right triangle is going to have, and so it says the tangent of theta, tangent is 5 over 12. Remember, tangent is opposite over adjacent. Opposite over adjacent. Now I do know that in this quadrant right here, since I'm going left, this 12 has to be negative. Since this 5 is going down, it has to be negative as well. So let's think about this Pythagorean triple we got here. We have a 5, 12, and 13. The hypotenuse is usually positive, okay? But that's going negative, that's going negative. Cool, sounds good. So I set up my triangle. Now what's it asking for? The secant. Don't go ahead and try to find the secant right off the bat. Let's think about it. Secant is the reciprocal of cosine. It's the reciprocal of cosine. So let's find the cosine of this, and then we'll just flip it. Okay? The cosine. Remember, cosine is adjacent over hypotenuse. Sorry, adjacent over hypotenuse. Okay? So we're going to find cosine, and the cosine of this is adjacent negative 12. So cosine of theta equals negative 12. So that's adjacent over hypotenuse over 13. Negative 12 over 3. But I'm not looking for cosine, I'm looking for secant. So we're just going to flip that. That's going to be negative 13 over 12 now. That's our final answer. Okay. So if I had asked you for, I don't know, the cosecant, well then that's simple. You'd find the sign and you flip the sign. Simple as that. Okay, and that's it for that. So that's it for video number 1. Video number 2, I will assign the homework after video number 2. We're going to be doing a little bit of double angle and a few other throwbacks as well.